In this first example, we are going to review the idea of converting a mixed number into an improper fraction. And even though it might seem kind of like shortcuts and trickery, what we're really doing is training our brain to see an amount in a different way. So if you look on the left side, there are two whole bars that are colored in. They are 1, 2, and then half of this next bar is colored in. I'm going to draw the same picture on the right side, except instead of having those top whole bars be in one part, I'm going to divide those bars so they look like the bottom bar in the same number of parts. So here's what I mean. Here's another bar. I'm going to drag it right over so you can see. See how it matches? I'm going to just drag it over to the side. And then I'm going to color in 2. All right, so now there's one whole bar for each of those. Then I'm going to make a copy of that. Here's another bar. And then I'm going to make one more. However, if you look straight to the left, I'll draw an arrow here. If you look to the left, you'll notice that that bar there is only half full. So I'm going to get rid of one of those. So now the amounts in all of the bars match. There are 2 holes on the left side and a half, but there's still 2 holes on the right side. 1, 2, whoops, let's try that again. 2 holes, 1, 2 and a half. But instead of seeing them as 1, 2 holes plus a half, I'm going to look at what's on the right side. I have 2 halves, I have 2 halves, and I have 1 half. I have 2 halves, I have 2 more halves, which gets us to 4, and I have 1 more half, which is 5. So I have 5 halves on the right side. Remember, the denominator tells us that each bar should be cut into 2, and they are. The bottom bar has 2 parts, but only 1 is colored in. So each bar is cut into 2, and that top number, 5, tells us how many parts we colored in. So 2.5 on the left side is the same as 5 halves. And the shortcut math way to write that is 2.5 equals or is the same as 5 halves. Okay, example number 2 uses the mixed number 4 3/5. So before I do the work on the right side, I'm going to think about this and kind of use my imagination to imagine that each of the holes on the left is cut into parts. And the number of parts really depends upon that last hole that got cut and then some of them colored. So this one got cut into, let's grab that again, 1, 2, 3, 4, 5. So I'm going to imagine that each of these bars got cut into 5. So if each of those top bars got cut into 5, it's like having 5 on the top, 5 here, 5 here, 5 here, and 5 here. That's 4 groups of 5. So I can think about that as 4 times 5, 4 groups of 5, or 5 plus 5 plus 5 plus 5. That's 20. Then I'm going to add on the 3 at the very end. So let me show where those are. I'm talking about these right here, 1, 2, 3. I'm going to add those on, plus 3, and I'm going to get to 23. So in this picture that I do on the right side, I should get to 23. Let's see if I do. Cut that into 5, and we'll move it over. Put it right about there. And we'll color it all in, because if we look at the top bar on the left side, that entire bar is colored in. All right, so I need 4 that are completely colored in. So there's 1, 2. Oh, let's put it down just a little bit. 2, is it gonna let me? 2, there we go. 3, 4, and then that last bar, I'm gonna copy. There we go. I'm going to copy that last one, but I need only 3 of those colored in. So I'll get rid of 2 of them. So at this point, I should have 23 colored in. I have 4 groups of 5. Right? 1, 2, 3, 4, 5. There's 5 on the top, 5 in the middles, 5, 5, 5, plus 3 more. So I should get to 23, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So that means that we were right. We have 4 groups of 5 plus the 3 left over. So I'm going to rewrite that down on the bottom. 4 3/5 on the left side is the same as, now I had 23 pieces on the other side. I'll write that in red. 23 pieces or parts that are colored in. Now be really careful. The denominator isn't 25, and that's what some kids want to think, because there are 25 total parts, but the denominator doesn't mean total parts. The denominator always tells us, if I were to add one more whole, how many parts would it get cut into? Each one of these is in 5 parts, so the denominator has to stay 5. Each whole is 5. There is a shortcut to convert a mixed number to an improper fraction without having to draw a picture. But it's really, really, really helpful to have a picture of what 2 3/8 or any mixed number looks like in your mind. All right, so here's 2 3/8 in purple strips. The shortcut way involves making a mixed number mad. I'm going to write in those letters. M, A, and D. So M stands for multiply. I'm going to put a little multiply symbol in between the 8 and the 2. So the very first thing I'm going to do is I'm going to multiply 8 times 2. And here's where that is in our work on the side. I'm going to cut it into 8 because that's what the denominator means. I'm going to color in all of those parts. Here is 8 times 2. Right here. 8 times 2. All right. Step 2 with the MAD method is to now add. I'm going to put a plus in between the 2 and the 3. The plus means I'm going to add 3 more colored in parts, and you can see them over here on the left. I'm going to make them show up again on the right. So I'm going to cut them into 8 and color in 3. There's my plus 3. Okay, I'm almost done. To change it into a mixed number, the last step is the denominator. And this is the trickiest part. You just have to remember that that 8 stays the same because every single whole got cut into 8. Again, we can't make it be 24. It's not how many little parts there are on this entire side. The denominator says in every whole it gets cut into 8. There are 8 here, there are 8 here, there are 8 here. Each denominator has 8. All right, now I'm just going to work my way around on the left side. 8 times 2 is 16, and then add 3 more. 16 plus 3 is 19. These two here are 16. Here is our plus 3. This is what the multiply add denominator, the MAD method is. Multiply the denominator times the whole number and add the numerator. If this is tricky for you, you can always draw a picture.